Hey boys and girls, I want to explain for myself how the dryer gas valve solenoid works and how it is connected. I've been trying to diagnose my dryer and I'm not that smart and I don't know how this thing works, but the way I understand it, I saw some diagrams here online. Your solenoid looks like this. It comes usually in two. This is the first solenoid and this is the second solenoid. Inside the first solenoid is a holding coil and a booster coil. See, it's got three prongs. One is a neutral coming from the drive motor. One is a hot wire. In my case it was a blue wire, and the other one is a white wire, which is hooked up to the secondary white wire and also to the flame sensor as well as the igniter. See that? This represents the first solenoid. So inside is a holding coil, a booster coil. This is the hot wire. See, it's hooked up to the secondary coil as well as to the first coil, and the white wire is also hooked up to this. To see, it hooks up to the flame sensor as well as the igniter. This one is the white wire. It goes to this thing, first solenoid. So when you turn on the dryer and you're asking for heat, current flows through here. Goes like that. It energizes the first coil. As current goes through here, it energizes this coil, and also this flame sensor is cold, so it is closed, so it gets connection. It energizes this booster coil as well, but most importantly it sends current also to the igniter, which glows real hot, which causes the flame sensor to disconnect because it's got a temperature sensitive thing that opens up once it gets hot enough. So now the current has no easy path to go this way, and the secondary coils, it has more resistance since it doesn't have a direct neutral like this one. The igniter has a direct neutral wire from the motor, so it likes to go this way when this is close. But since this is now interrupted after it gets hot, the current now has no choice but to go here to the next least resistant path. It goes to the secondary coil, and now this gets energized. That's when you hear a click, and the secondary coil activates or opens the gate, the valve for the gas to flow. And this happens in a split second. As this disconnects, current automatically flows here, opens the valve, and as the igniter loses its current, the valve opens almost simultaneously, which causes gas to ignite. And so the current will be continuously flowing through this two solenoids, or these three coils, and keeps giving gas until the thermostat, cycling thermostat, or the high limit thermostat, or the thermal fuse gets disconnected, or if you shuts off the board, the control, or going this side, because this motor neutral, the neutral from the motor is hooked up to the neutral all the way going through your door switch, the dryer door switch, and then to the main outlet plug. So if you open your door, it also shuts the dryer, because now there is no closed circuit. You're losing the loop, so no more neutral when you open the door, because the door neutral goes to the motor. So it shuts the motor, it shuts the gas, everything shuts down when you open the door of the dryer. Okay. See this booster coil and the secondary coil? It shares the neutral. So that's why when you turn it on first, the current doesn't want to go here, because it gets so like there's a lot of obstacles to overcome. But when this gets hot enough that it expands and loses contact, your current now flows to the secondary coil. But it also also see the secondary coil also connected to the igniter, but it doesn't, since it goes to the secondary coil, it loses some of the current, so it doesn't have enough current to ignite, to make the igniter glow, but it has enough current to open the valve that completes the circuit. So it energizes these three coils, but not the igniter, so this loses power. Okay, I'm making this recording to remind myself also when I come back and diagnose this dryer in the future. Bye.